Okay, so today, 12-1 day 2, independent events. Two events are independent events if and only if the occurrence of one event does not affect the probability of the second event. Okay, so so I almost like to view independent events as the fact that they do not share that Venn diagram. Okay, you have two different things going on here. So remember yesterday I used the example of, for mutually exclusive events, we use the examples of cats and fish. Those still have something common where they're pets, they're just not going to have that merging intersection. Independent means that they are totally random to each other. Okay? So it would be like surveying and seeing if people have pet cats but then play baseball. Like the two of those don't really mesh. Okay? So that's what's happening here. So if we take a look at just this little itty bitty part underneath, you have the actual theorem and the corollary here, believe it or not. If A and B are independent events, then you can multiply the two together to find the intersection, or that A times B. Okay. If A and B equals the probability A times probability B, then A and B are independent events. So it can flip flop. Okay. They might ask you, hey, this is happening. What are they? Are they mutually exclusive? Are they not mutually exclusive? Are they independent? They can ask you a question like that. Okay. But as you can see here in this example, it says there are 12 possible outcomes from the independent event rolling a number cube and tossing a coin. These two are not related, right? Everything's going to have its own unique probability. So if we're talking about the probability of getting a 4 on the die, that's 1/6. The probability of flipping the coin and getting ahead is 1/2. Now, the probability of a 4 and ahead is going to be 1/6 times 1/2, which leaves you with 1/12. Okay. So just keep in mind, these are not necessarily mutually exclusive, but they are independent of one another. All right, so let's take a look at this first example. So Alex cannot decide which shirt to wear today, so she chooses one at random. The probability of rain today is 40% or 2/5. What is the probability that Alex chooses a yellow shirt and it does not rain? All right, so the first thing we're going to do is we're going to look at the probability of a yellow shirt. Can you guys see that? I'm trying to stick with colors if I can. Now there are 2 yellow shirts out of the 4, so that's 2 over 4, which gives us a total of 1/2 probability of her selecting a yellow shirt. Now we have to talk about the probability of it not raining. Okay? Now they're calling it N, but as you can see here, they put the probability of rain is 40%. So what we're actually doing is we're finding the probability of rain complement. Remember that from yesterday? But they're just calling it P of N. So this means we're going to take 1 minus the 2 over 5, which leaves us with a total of, I think it was 3 over 5. Does everybody see where that's coming from? Okay. All right, now if we want to find that, the probability of Y and no rain, it's going to be 1/2 times 3 over 5, which gives us a total of 3 over 10. Or you can say 30%. questions on that? Oop. Anybody still writing? Okay. So the next one, it says, example 2, a jar contains 12 green marbles and 8 violet marbles. A marble is chosen at random from the jar and replaced. So if I had a bunch of marbles in there, I would pick one. Ooh, what color do I have? Record the results, pop it back in. Okay. So it says, another marble is chosen at random from the other jar. Does the color of the first marble chosen affect the possible outcomes for the second marble chosen? What do we think? And you're shaking your head. Why? Yeah, nothing changes with that probability because we're putting it back. Without replacement is a different thing. We'll be talking about that probably next week. Okay. All right. So that means I'm just going to kind of give you guys this one to write down. So it says the first choice you would have is the probability of selecting a green would be 12 over 20, which is 3/5, and the probability of selecting a violet would be 8 over 20, which is 2/5. The second choice is going to be exactly the same. So since those probabilities are the same, no, the color of the first marble chosen does not affect the possible outcomes for the second when it is replaced. All right. Anybody still writing that down? If you are, please raise your hand. Okay. All right, let's just take a look at this backside here. So the biggest part that I want you guys to kind of keep in mind with this are this whole wording. That's kind of the biggest deal here. Not that the algebra and the examples aren't important, it's just the wording usually helps with stuff like this. If we're talking about mutually exclusive events, they're saying A and B are mutually exclusive because no outcome is both A and B. So one thing you're going to want to note here is that this shares a Venn diagram. And that's so we can find, those commonalities, if they exist. The independent events, it says D and M are independent because of the occurrence of one does not affect the probability of the other. In this case, this is not going to share a Venn diagram. Because you are talking about two completely separate things. A Venn diagram and that mutually exclusive part basically states, hey, there is something in common, there's just not going to be that and portion. Nothing's going to merge. Independent means, these are like completely like on their own, guys. All right. Any questions? All right. Homework for tonight is going to be, whoop, didn't want to do that. It's going to be these you try it's, okay? And then you have those two ed puzzles that kind of help break up a little bit more about mutually exclusive, and it's going to review a lot from yesterday and the independent events, okay? Feel free to use your headphones if you need to. I'm fine with that. Just make sure, please get those done. You should have plenty of time. And those of you watching at home, have a great day.